Because storage that scales out means the potential for many nodes, it would be time-consuming to maintain and upgrade them individually. ScaleIO is hypervisor independent, so it can't rely on a specific hypervisor to facilitate upgrades. It takes care of its own coordination and clustering. Furthermore, ScaleIO can deploy over 1,000 nodes in the same storage system, so making maintenance and upgrades seamless and automated is vitally important. We need a way to coordinate the upgrade and maintenance procedure across the system, and it needs to be simple, centralized, and automated. Furthermore, it has to be non-disruptive. It shouldn't interrupt I/O, and it shouldn't interrupt other storage tasks. Fortunately, the ScaleIO management server and GUI can do exactly this. That's what I'm going to demonstrate. First, a quick overview, and then we'll see it in action. Here we have a ScaleIO cluster that's 6 total nodes. Some of them have 10 drive bays, and some of them have 24 drive bays. All of them have both spinning hard drives and solid-state drives with flash storage, SSDs. SSDs in every node are used as caching for the hard drives, and the nodes with more SSDs are using the rest for a separate storage pool. Data stored in the system is striped across the drives in all of these nodes and mirrored, so ScaleIO could lose one of these nodes, or put the node in maintenance mode without any disruption in service. All of these nodes are also part of a VMware ESX cluster running vSphere, so this environment has its hypervisor and storage converged. Let's look at the components involved, and you'll see why this is a complex but automatable procedure. First, there's the management server. This is hosted outside the pool of nodes running ScaleIO. Next, there's the metadata manager, or MDM. This keeps track of all the storage system components and tells them where to find each other. There are multiple copies running, but only one of them is authoritative. Any given ScaleIO system will have either 3 or 5 total metadata manager instances. The rest are backup copies, or tiebreakers, used to keep the system resilient. No user data flows through the MDM. It's only responsible for coordinating. Then there's the ScaleIO data server. In the case of our ESX cluster, this is a special VM guest that has direct access to all the physical disks in the node where it resides. Next, the ScaleIO data client. This is a kernel module that will present the storage that's on all of these nodes and make it look like a single volume. The ESXi hypervisor. It's both providing storage using the ScaleIO data server in that VM guest and consuming storage from every other ScaleIO data server with its client. We've turned all of these nodes into a cluster in vCenter so that we can migrate guests between nodes. Finally, there are the VM guests in this cluster running applications. In our case, we just have a few, and they're configured to read and write from all the storage continuously while the upgrade process is underway. I want to emphasize that all of the clients are accessing a given server during normal operation. And any client is going to need to access all of the ScaleIO data servers in order to retrieve data. It's a scenario where all of the data is laid out in a high throughput, low latency mesh and mirrored, so there won't be any interruption to service while these nodes are being upgraded. Here is how it's going to go. The management server sends a signal to the ScaleIO server components running on the node. Now they're in maintenance mode, and the other nodes in the system are going to continue operating without them. The ScaleIO data server gets upgraded. Now the MDM gets upgraded. But we still have the ScaleIO client software to upgrade, and that's going to mean stopping the ESX hypervisor on this node from accessing data on our ScaleIO volume. So, the ScaleIO management server tells vSphere to move the VM guests to other nodes via vMotion. There's no interruption in service, and vCenter's Distributed Resource Scheduler, or DRS, makes sure that the guests end up on the right node. That leaves this node clear to upgrade the ScaleIO client without any traffic going to the data servers. Now we can bring the ESX node back online, let DRS migrate VM guests again. Here we take the ScaleIO data server out of maintenance mode, bring the MDM back online, and we're up and running and fully upgraded on this node. The management server running the upgrade process just moves on to the next one, repeating the same steps until all the nodes have been upgraded. Now that it's clear what the upgrade process consists of, time to watch it in action. Here we've got the ScaleIO GUI. Now we'll take a moment to start VDBench so that there's some traffic running in the background, both reads and writes. Now we can open the upgrade dialog. We have a ScaleIO supplied upgrade package here that will load in to identify the destination version. In this case, we're upgrading from 2.0.1.1 to 2.0.1.2. When it's uploaded, click OK and the procedure begins. Here on the left is the list of nodes that are awaiting an upgrade. You can see that the list is split into two parts: the nodes that have MDM components that need upgrading, and the nodes that don't. Since we have a full roster of MDM roles, we have 5 of these nodes. Even if we had a much larger cluster, it would still be 5. Returning to the dashboard is just a matter of clicking the tab at the top, and we can move back and forth between the upgrade process and anything else we might need to do while it's still running. At this point, ScaleIO has told vCenter to migrate the VMs off of this node and onto other nodes in the cluster. In our case, we have one VM generating a lot of load rather than many VMs each generating a little, so the move will be extremely fast. Clusters that have a large population of VMs might need a little longer for this step. From here on out, we're just going to be watching the tasks ticked off one by one. In the background, nodes will be going into maintenance mode. They'll have their VM guests migrated to other nodes. They'll have their storage software upgraded. All we need to do is sit back and watch. At this point, I'll speed up playback, and we'll see the nodes get upgraded one by one, and the upgraded list on the right gradually fill up. Note that in the upper right of the upgrade pane, you can keep track of how long has elapsed for the current upgrade process. Four nodes down, just 2 more to go. There we have it. All of our nodes have been upgraded. We can see on the timer that it took approximately 14 minutes. And we can see that VDBench is still running its load generators across the nodes. Traffic is still being generated. And here's where we've ended up. The thought of upgrading many nodes in a scale-out storage cluster might seem daunting or time-consuming, but ScaleIO has a built-in method for performing non-disruptive upgrades, even in environments where storage and hypervisors are converged, in a seamless and automated way.